This is my explain the material assignment for the absolute value and types of function assignment. So I already have the two graphs written out, and we'll first show you the f of x equals the absolute value of x plus 2. This plus 2 is important because when you're graphing it, this plus means actually you're going to the left 2 spaces. If it was minus 2, you'd be going to the right. So if we graph the absolute value of x plus 2, we have a point at x equals negative 2, and then we go up in straight linear lines in both directions. So that is our f of x equals absolute value of x plus 2. And then g of x equals just plain old x plus 8. So it's x plus 8, remember, if it's a plus, we go to the left 8 spaces. And it's not absolute value, it's not squared, it's just plain old x plus 8, so it's a linear line. Or a linear increasing line, I mean. So we go back 8 spaces, and then just line straight up. Alright, so we need to find out what the solution is, and that means where these two lines intersect. And they intersect at negative 5, 3. My lines aren't perfect, I'll admit, but that is where they would intersect if you would put them in on a graphing calculator, and you can see them drawn out perfectly. So the answer is m negative 5, 3. Alright, so for the next one, some values for function w of x and z of x are shown in the table. You have the table here. Which statement best describes the functions? So I have w of x written out here. I have the graph and then the line shown here with the points drawn out. So we have 0, 1, 2 and 1.9, 4 and 3.6, 6 and 6.8, and 8 and 12.9. And you can see that this is an exponential increase, an exponential function. Let's see. Then for, I didn't mark z of x. This graph down here is z of x. If you were to look at the graph, we have 0 and 9, as is shown here, 2 and negative 3, 4 and negative 7, 6, negative 3, and again 8 and 9. So we graphed that, and this is a quadratic function. Quadratic. Now, if we go up here, we want to see which statement best describes the functions. So, w of x is exponential, that's correct. Z of x is a polynomial. Well, quadratic and polynomials are similar, but it's not what we want. Bone just dropped. Alright, sorry about that. So w of x is a polynomial function, and z of x is an exponential. Well, go up to w of x. Obviously not a polynomial function, so this is incorrect. W of x is a polynomial, so far so good. Z of x is a logarithmic. Nope, that's not what we want. W of x is a trigonomic function, and z of x is a polynomial. Again, w of x, very clearly exponential. So this is incorrect. And you may be wondering what a polynomial function looks like. So I will draw one out. Let's see. An example of one would be, so far it looks like a quadratic, but it also curves back up like so. That's a polynomial function. And that is the closest to quadratic, and that is why A is correct. W of x is exponential, and Z of x is a polynomial. All right, that's my explained material assignment.